Okay, so in this problem, it's going to be similar to a previous one that we did. We need to simplify all of this stuff into just a single sine function or cosine function of a single angle. And maybe that angle is not a special angle on the unit circle. It probably is not. But the point is, I want sine of something or cosine of something. And we have to figure out how to get there using the summation identities. That's what this unit is all about. We'll get to other identities later, but for now, I just want to keep focusing on the summation identities. And as you look at this thing, there should be some warning bells going off in your head, because look at this. Sine, sine, sine. It's all sines. It's all sines all the way across. And our identities were always a mix. We had sine, cosine, cosine, sine, or maybe a cosine, cosine, sine, sine, right? But we always had a healthy mix of sines and cosines. Not in this one. We've got all sines. It's a pure sine thing. We need to simplify it. Well, I'm going to encourage you to pause the video here and see if you can use any of the structure of this to remind you or prompt you to think about this as an identity. Sine, sine minus sine, sine. What does it seem similar to? Okay. Personally, I think this seems similar to cosine, cosine minus sine, sine. Is there a way we can turn this into cosine of something times cosine of something? Well, I just got finished in a previous video telling you how stupid the cofunction identities were. The things that said stuff like this. Sine of 90 degrees minus x equals cosine of x, and how rare it is that you would actually use this thing. Well, okay, so we're going to use it. We're going to use this one. If you don't remember this relationship, it's very easy to rederive using the summation identity on that right there. Okay, but this is one case where it actually does come in handy. So I'm going to think about it. I'm going to try to think about it this way. Another cofunction identity is this. Cosine of 90 minus x equals sine of x. And I think that one's even more useful, because if I say x is 29 degrees, that tells me this is cosine of 90 degrees minus 29 degrees times cosine of 90 degrees minus 169 degrees. Okay, that looks bad, but just hang on. And then we have the rest of the problem. Minus sine of 61 degrees, sine of negative 79 degrees, right there. Okay, so this is what I've turned it into using the cofunction identities. I take back everything bad I said about them. They turned out to be useful this time. Now, what's 90 minus 29? Oh, look at that. Not coincidentally, it is 61 degrees. And what is this other thing over here? 90 minus 169. That is negative 79 degrees. So look what I've got. I've got something that is very similar to my cosine, right? My cosine summation identity, which is cos minus sine sine. Cosine changes the silly sign. Now, because cosine changes the silly sign, right? What's my sign? It's this minus sign right there. So cosine changes that silly sign. This is going to be a plus when I turn that back into a single cosine. So it's going to be cosine of something plus something. And what are my two angles? Well, 61 degrees and negative 79 degrees. Okay, well, 61 minus 79, this is going to be where I get stuck. Negative 18, I think negative 18 degrees. Okay, by the even-odd identity, cosine's an even function, so this becomes cosine of 18 degrees. You could have said cosine of negative 18 or cosine of positive 18. It doesn't matter, just for argument's sake, I'll just say negative 18. Okay, and then you approach this one the same way, except for that one, I would suggest using this identity right here, this cofunction identity, where you change some of those cosines into sines, and then you'll have your way back to a cosine summation identity.